Mars is a cold planet because the distance with the Sun. The South and North Pole in Mars are very similar to those on Earth. There are the coldest places in the planet with temperatures from minus 150 degrees. In the equator, the temperatures are over 20 degrees. Comparing this with the temperature on Earth, we have a very big difference. In Earth, the North and South Pole have a temperature of minus 70 degrees, and in the equator is over 27 degrees. The carbon is essential for life. Without this, vital elements doesn't exist. Unfortunately, Mars has carbon, oxygen, and nitrogen, the principal elements for life. Also, in the South Pole, under an ice cap, Mars has water. This makes that the possibility of life there becomes more real. Protecting from radiation. The radiation and dust storms are very common in Mars, but there is a way to be safe of these caves. This is the result of previous volcanic activity. A. Location. So, with this information, we can determine that the best place to live in Mars is close to the equator. B. Why? Because the difference of temperature is not that much. Also, there are carbon, oxygen, and nitrogen in this area, making the possibility of life better. C. Pros. In the equator zone, there are caves that can be used as a refuge from radiation and dust storms. The temperature is similar with the Earth. The vital elements are present there. D. Cons. In Mars, the water is found in the poles because of the glaciers, but the life in poles are not a possibility due to the extremely cold.
Radiation. Radiation is a very important hazard to address as far as the Martian colony. This is because the radiation is a very relevant and dangerous hazard that the astronauts will be exposed to if the travel is ever completed. This is because Mars, unlike Earth, has a very thin atmosphere and a very lacking electromagnetic shielding. So, it is very highly exposed to radiation coming from space or the sun. What we need to do to compensate for this lack of atmosphere and protection is to shield the astronauts ourselves. What we have for this are our own tools and structures, which we would reasonably want to make out of radiation shielding elements. These include hydrogen, nitrogen, and boron. And it just so happens that NASA has developed a very promising compound out of all of these. The boron nitride nanotubules are a product that has been created by NASA, and not only that, has a potential for growth as being hydrogenated boron nitride nanotubules, which combine the power of all those previously stated elements for the shielding of radiation.
For the first point, we need to understand that there is oxygen present in Mars, and it is present in the ice cubes that are located in the surface. Oxygen can also be obtained by dividing the CO2 into its primary components, which are oxygen and carbon. The separation turns out that it's created because in a highly excited state, carbon dioxide and other molecules have a bit more energy to skip that minimum energy path, and like any agitated person or molecule, feel the roaming, which is a chemical phenomenon in which chemicals bond will break in other ways. So that's the reason why oxygen and carbon are separated. So our answers are for point A, separation by laser; B, the procedure that I explained earlier; C, the pros are separation of oxygen and carbon into atoms; and the cons are the high energy concentration that is needed in order to divide. Also, it's important to take in consideration that the biggest amount of oxygen produced in the planet is produced in oceans by algae oxygen production, and this is plankton mostly.
Water on Mars. In Mars exists a type of carbon that is combined with another molecules, include oxygen, nitrogen, and hydrogen. So the vital molecules for life are already there. In the south pole of Mars, the water is present, but it is considered like salad water, so it can be drink, but there are ways to make it pourable. A. Method of choice. Transform salad water into a potable water. B. Why? The salad water in Mars is on the poles, so in a specific season, the ice from the glaciers is going to melt, becoming all liquid water. The method that we will take advantage of is the sun season. Then recollect water and transform into a potable water. C. Pros. The good part of this is that we don't waste water or natural resources. We only take advantage of them. D. Cons. The worst part is that it is only effective on the sun season.
For the power source question, how will you support the power needed of a 5-person crew over the 500-day mission? This is our answer. For point A, it's nuclear power. For point B, the justification is because it does not depend on external factors in order to operate, unlike solar energy. This means offering prolonged life and reliability could produce from 1 to 10 kilowatts of electrical power, continuously from 10 years or more, taking into account that the US household runs about 5 kilowatts of power. The prototype will consist in a cast uranium with a value of 235, which is an isotope, and the size of a paper towel roll. The pros of these types of power is that it's non-dependent in external factors like sun or wind, and the cons is that it's not always safe to manage. And that's for point C and D.